Hey, what's up everybody? My name is Moss, and in this video, I'm going to introduce you to Splunk Observability Cloud's K8s Navigators and Autodetect Detectors and Alerts. We're going to discuss and demonstrate the following topics. If at any point you'd like to skip to a particular topic, you can use the chapter markers that we've included in the video description below. What is K8s Navigator? And what are Autodetect Detectors and Alerts? We'll do a walkthrough of K8s Navigator in Splunk Observability Cloud. I'm going to deploy a service to a cluster and troubleshoot the deployment using Autodetect alerts. I'll deploy a load generator and will monitor K8 services under load. I'll also show you how to use related content and logs to troubleshoot a service. We'll then walk through monitoring K8 services using built-in dashboards. The Kubernetes Navigator enables you to monitor critical health metrics of your Kubernetes clusters from within Splunk Observability Cloud, and it can be found within the infrastructure landing page. Here are some of the features that the K8s Navigator offers. The first is the K8s Analyzer. This is a powerful troubleshooting tool that highlights problems in your K8s environment and automatically groups objects with those problems based on common attributes. Now, although I've been referring to the K8s Navigator as a single entity, it's actually split into two subtypes, the first being the K8s Nodes Navigator. The Nodes Navigator provides a dynamic view of the nodes in your Kubernetes clusters, and it allows you to view critical node metrics such as CPU, disk, and network utilization, among others. It also allows you to filter nodes based on a large number of attributes. For instance, I might want to see only nodes in clusters with failing pods. The second type of the K8s Navigator is called the K8s Workloads Navigator. Like the Nodes Navigator, it provides a dynamic view of the workloads across K8s clusters. An example of a workload might be a Kubernetes deployment or a daemon set. Within this navigator, you can view critical metrics like CPU, disk, and network utilization at the workload and pod level. And you have the same filtering functionality that you do with the Nodes Navigator. Now let's talk about Autodetect detectors and alerts. Autodetect detectors and alerts are automatically added to Splunk Observability Cloud when you have configured the supported configurations, and they're available in Splunk APM and infrastructure monitoring. And they provide detection and alerting of some of the most common problems in your environment. Detectors are available for more than just Kubernetes environments, but today we're only going to focus on the Kubernetes-specific detectors. Let's take a look at the detectors that are available for Kubernetes. The first is the cluster daemon set ready versus scheduled detector, and this will alert when the number of ready and scheduled daemon sets have diverged. The next detector is cluster deployment is not at spec, and this will alert when the number of ready and available pods in cluster deployments have diverged. This detector will alert when the container restart count in the last 5 minutes is greater than 0. The node memory utilization is high detector will alert when a Kubernetes node has been using more than 90% memory utilization for 5 minutes. This detector will alert when a Kubernetes node is not in a ready state after 30 seconds. Now that we have a high-level overview of what these features are, let's take a closer look at them in Splunk Observability Cloud. Okay, so I'm at the home page of Splunk Observability Cloud, and in order to navigate to the Kubernetes Navigator, I'll want to go to the Infrastructure Monitoring page. I can navigate there using the Infrastructure tab here, or if I expand the sidebar, I could navigate to the Infrastructure page using the sidebar here. Now from the Infrastructure Monitoring page, I'm going to navigate down to the Containers section, and then I'm going to select Kubernetes. Now these two entities listed here are the Kubernetes navigators that I was previously talking about. The first one is the Kubernetes Nodes Navigator, and the second is the Kubernetes Workloads Navigator. We're going to take a look at the Kubernetes Nodes Navigator first. The Nodes Navigator provides a heat map view of my nodes and clusters. In this heat map view, I have 3 separate clusters, and within each of these clusters, I only have one node. If I hover over the outermost cluster box, I can see how many nodes are in this cluster and the cluster name. If I hover over the blue box, which is the node in the cluster, I can see more metadata about that specific node. For instance, I can see how many pods are running in the node, as well as the node condition, which the node is ready. The string at the top of the metadata is the name of this particular node. Now, if I hover over one of these individual green squares, these are the actual pods that are running on the node. And again, similar to nodes, I can see additional metadata about this pod. For instance, I can see the pod name, the node it's associated with, the cluster it's associated with, as well as the pod phase, which in this case it's exceeded, and how many containers are running in this pod. If I scroll down on this page, I can see several tabs which contain critical data about my Kubernetes nodes and clusters. These charts that you see here are provided by default when you've configured the Kubernetes integration. If I click on the K8s Clusters tab, I can then get cluster-wide node metrics. And if your K8s nodes are pushing logs as well, we can see those node logs from the K8s Node Logs tab. And in our case, we don't have those logs configured, so it's not pushing any logs currently. The final tab is the K8s Analyzer. As I mentioned in the slide presentation, the K8s Analyzer is a powerful troubleshooting tool that will automatically detect problems and then attempt to group Kubernetes objects with related attributes that have those issues. So for instance, in this first tab, you can see that it will list objects, Kubernetes objects related to restarted containers. And so if I expand this list under this particular cluster, I can see a list of those objects that are related to restarted containers in the cluster. The Nodes Navigator also has service discovery functionality. So you'll notice in the Nodes dependency section here that it's detected an instance of Apache running in one of the clusters. And this is dynamic, so if I click Go to all Apache instances, it will then show me a page where I can view the statistics around that particular Apache web server. Let's drill down into a particular node in this heat map. So I'm going to select this node here. You'll notice that we click into a single node, we get a more detailed view of the pods running in that node, as well as the containers running inside of the pod. You can see how many containers are running in a particular pod by the number of rectangles here. And then if you hover over one of those rectangles, you can get metadata about that particular container. In this case, the container is core DNS, and we can see that the container status is ready. And if you hover over one that's red, you can see that it's colored by the container status. So in this case, the container is not ready. And also notice that we can use these drop-down menus to view a different cluster and also view different nodes within a cluster. On the right-hand side, we can see all of the K8s native attributes that are associated with this particular node. And similar to the cluster-wide view, we can get more specific metrics about this particular node using the tabs at the bottom. So if I select K8s node, I can see more detailed metrics about this specific node, as well as the pods and workloads that are running on this node. And I can select the K8s pods tab to get more detailed information about the pods that are running on this particular node. Again, for this particular example, we're not pushing node logs in this case, but this is where we would be able to see the node logs. The K8s Analyzer is also available at the node level, so we would be able to see any kind of patterns that the analyzer identifies at the node level as well. Let's again drill down further into a specific pod on this node, I'm going to select the one with multiple containers actually. So at the top, I still have a heat map view of the pod as well as the containers running in the pod. So I can see the container name, the status, and then I also have detailed metadata about the pod on the right-hand pane as well. And if I scroll down, I can see pod-specific metrics, like the number of active containers in the pod, and also resource metrics as well that are at the pod level. If I select Kate's containers, I can then get detailed information about the actual containers and their resource usage. In this example, we're not pushing the pod logs, but if we were pushing the pod logs, we would be able to view it from this tab here. And again, similar to the nodes and the cluster level, we can view the Kate's analyzer at the pod level as well. I'm going to navigate back to the top level nodes navigator. Now that we've seen some of the major features of the Nodes Navigator, let's take a look at the Workloads Navigator. And I can change to the Workloads Navigator by coming to the Entity dropdown and selecting Kubernetes Workloads. The first thing that you might notice here is that the workloads are not displayed in a heat map. They're displayed in a list. So if I look down here, I can see the namespaces and then the specific workloads under those namespaces if I expand the namespace dropdown. If you'd prefer to see the heat map of the workloads, then you can come up here to this icon, the list icon, and then select the icon directly next to it. And now, similar to the Nodes Navigator, we have a heat map of the workloads, and they're currently grouped by the Kate's namespace name. I also have this additional dropdown, which will color the workloads by the number of pods failed, or I can select other states or phases of the pods, as well as file system usage and the network transferred in bytes. Since none of the pods have failed, these workloads are all of the same color, but I think if I select file system usage, we might see different colors. So here you'll notice that there's different shading for each of the workloads based off of their file system usage. And again, in the group by dropdown, this heat map is dynamically updated even when I hover over various dimensions to group the workloads by. And if I scroll down to the Kate's Workloads tab, I can get some pretty key metrics about the workloads that are running in my environment. For instance, I can get the number of workloads, file system usage by workload, network transferred in bytes by workload as well. Similar to the Nodes Navigator, these charts are built-in charts that you don't have to build yourself. When you have this integration set up, these charts will display automatically. And these tables will give you kind of a high-level overview of whether or not a particular deployment, daemon set, or replica set is not at spec. One thing that I didn't mention in the Nodes Navigator, but is available in both the Nodes Navigator as well as Workloads, is this time window selection dropdown. So right now I have the last 8 days of data selected, but I could also update this to be a smaller or larger time frame. Additionally, I have this filtering feature where I can filter based off of various attributes of the Kubernetes components. So for instance, here I might want to filter on the workload name. And we're going to select the PHP Apache workload. Just like the time window selection, this filtering option is available in the Kubernetes Nodes Navigator. I'm going to click on this workload and take a look at the detail page for this workload. If you look at the right-hand side pane, you'll notice that the service discovery mechanism recognizes that this workload is running an instance of Apache. And then on the main page, you can view key metrics related to that workload, such as the total memory requested by containers and then requested memory by containers over time. This is also a good way to audit the limits that have been set for a particular workload. And then if I go to the pods tab, I can see more detailed metrics related to the pods. And these are similar metrics that you might have seen on the nodes navigator, but now at the pod level. I'm going to navigate back to the nodes navigator. And I'm going to exit this filter. Now remember that I have 3 clusters here, and each cluster has 1 node. One of the clusters is already running the Apache service, but I do want to deploy the Apache service to my own cluster. And that's going to be this cluster here and this particular node. So I'm going to log into that node and then deploy the Apache service on that node. Let's quickly take a look at the manifest for that Apache service. So if I scroll up, you can see that this is a stateful set that will deploy PHP Apache. And also notice the resource limits that are being set and that we're going to be running one replica. And then we have a service name here, PHP Apache service. That definition for the service is down here. I do want to confirm which cluster this node is located in. And we do have that saved as an environment variable. So if I echo the instance cluster, I can see that I'm in the right, the cluster that I do want to be in, which is this cluster here. And if I enter K9s, I can kind of take a look at what namespaces are currently in the cluster. We only have the default namespace, and I want to create a new dedicated namespace for this Apache service. So to create that namespace, I'm going to run a kube control, create namespace Apache, and that created the namespace. The next thing that I want to do is actually deploy the Apache service into the Apache namespace. So I'm going to paste this command in that will apply that PHP Apache manifest, and then we're specifying the namespace as Apache. Okay, and it looks like it did successfully create the stateful set in the service, but we could verify that with another command. And also you'll notice that once that service was created, this pod went briefly, it went orange because it was in a pending status, and it is no longer in a pending status because it has been scheduled and is running. I'm going to paste in a command here to get the status of that stateful set. And as you can see from the status, that stateful set is not ready. I'm going to try and grab the status again because it should be running. And as you can see, it's still not ready. So it looks like something's wrong. And we can take a look at the interface to investigate further. So I'm going to select this cluster here. So in the top right of the screen, you'll notice that I have one alert. And if I click on that, it's one major alert, and this label here called auto indicates that this is an Autodetect detector that has been triggered, and the severity is major. This particular detector is alerting because a container is restarted, and it may have restarted more than once. So I'm going to select this detector. So this alert was triggered 3 minutes ago, and in the detail view, which has a resolution of 10 seconds, you'll notice that the value is peaking at 4. So we've had 4 restarts. So something is going wrong with our deployment. Now, if we take a look at the signal details, I can actually see which containers are restarting as well as the cluster that those containers are associated with. And it is my cluster and the deployment that I just attempted to deploy. I can also select the node that this Apache service is deployed on, and we might be able to see a more detailed view of the specific containers. So in this case, it looks like the application is not even able to run because the container is being restarted. But I did want to demonstrate the auto detect alerts that you get when these containers are restarted. Again, this is just one example of an alert, but I can view additional alerts by navigating to the sidebar here and selecting detectors and SLOs. And from this page, I can view alerts from auto-detect detectors as well as custom detectors that I've created. From this tab, I can view active alerts, but if I navigate to the Detectors tab, I can see all of the detectors that are available to me, and the auto detect detectors are labeled with this auto label right here. And I can filter for those auto detect detectors, specifically for Kates, just by typing in Kates. And we can see the same detectors that I pointed out in the slide deck presentation are located here as well. And we can click on one to view its configuration. So from this configuration page, you can see how it's configured in terms of the trigger sensitivity as well as the clear sensitivity, meaning how quickly, when the condition is met, how quickly will this alert be triggered. And for this one, it's 80% of a 5-minute time span. And for the clear sensitivity, it's 100% of the condition met for a 10-minute time span. And the condition that we're talking about here is when the container has been when the container restart count is greater than 0 in the last 5 minutes. Now these auto detect detectors are read only, but I can create a customized version of the auto detect detector in the event that I wanted to configure it differently. Maybe I wanted to change the sensitivity of this detector. I'm going to navigate back to our Kubernetes navigators now. Now for this particular issue, I'm not going to walk through the troubleshooting steps. I do know what the root cause of this issue is, and it's that the resource limits and requests were not correctly set. Specifically, the CPU requests and limits were too high, and the memory requests and limits were too low. And so that was resulting in a crash loop back off. I've since adjusted the resource limits and requests. So if I go into my node in the cluster, I should be able to see the PHP Apache container running, and it looks like it currently is running successfully. For the purposes of this video, I just wanted to demonstrate what an auto detector alert would look like in the interface, as well as where you can find the auto detect detectors. The next thing that I want to do is deploy a load generator, and that load generator is going to apply load to this Apache service, which should result in an increase in resource utilization, which we'll be able to view from this interface. Now I've started 2 instances of the load generator, and you can see those containers here and here. If I scroll down to the node's metrics, you can almost immediately see a spike in CPU usage starting in the last couple of minutes, as well as the CPU used per pod. And then you should be able to see memory increasing as well over time. And remember that this load generator is going to be hitting the Apache service. And you can see in this chart, top pods by CPU usage, that the PHP Apache pod is consuming the largest percentage of CPU utilization. I'm going to actually navigate into the PHP Apache pod, and then we should be able to see those metrics in more detail at the pod level. And just like at the node level, you can see those metrics spiking at the pod level as well. And just to see how much pressure we can put on this Apache service, I'm going to increase the number of replicas for the load generator and double it. So I've doubled the number of load generators. I'm going to decrease the time window so that we can kind of see more clearly how the resource usage is increasing. And as you can see here, the memory usage is spiking to almost 90%. But just keep in mind that this metric is at the pod level, and the amount of memory that's allocated to this particular workload is small relative to the available memory on the actual node that this workload is running on. So for that reason, we're not getting any alerts from the Autodetect detectors that monitor the node memory utilization. Now, after I increased the number of load generators, the PHP Apache container was able to run for a few minutes before it ran out of memory and was under too much memory pressure. And so it was that container was terminated. And we did receive an alert from one of our Autodetect detectors for a container restart. And as you can see, the signal value for the container restart was once, and the container name was PHP Apache in my cluster. Now, if I wanted to keep the same number of load generators running, I might want to activate horizontal pod scaling in my Kubernetes cluster and increase the max number of replicas so that it could scale the number of Apache services, Apache pods that are running in the cluster, and it would be able to handle the number of requests that it's getting from the load generator. I'm going to go ahead and scale the load generator back down to 2 instances. I'm going to show you a feature that I think is really powerful. And to do that, I'm going to switch the organization that I'm currently in this Splunk Observability Cloud instance. To do that, I have to go up to the top left here to this dropdown. And I'm currently in this Splunk organization. And I'm going to select the target organization. Now I'm going to navigate to this feature in reverse a little bit. So if I go here to the log observer, you'll see various log entries for all of the containers and other infrastructure that's running in this environment. And if I select one of these log entries, I can view the full details of the log entry. But in addition to that, you'll notice these 2 bars down here at the bottom, infrastructure and APM. I'm going to select the infrastructure one, and it shows me related infrastructure to this particular log entry, which is a Kubernetes container. So I'm going to select that, and it'll take me directly to the container that is responsible for that log entry. Now, I said before, I'm kind of doing this in reverse because I'm going from log observer to the container. But really what would happen is you're viewing your Kubernetes node navigator, and you identify pods that are experiencing errors or failing. And if you were to go into the particular container that's failing, you would be able to see, if you've set up the integrations, you would be able to see these bars at the bottom with entries for related content, specifically the logs. So now I have a hyperlink directly to log entries related to this Kubernetes container, and this will take me directly to log observer. And in the results here, you'll notice that it's filtered specifically for that container. So these are all of the log entries over time for that particular container. Now I'm going to navigate back to that Kubernetes container. In addition to the related logs, I also have entries for related APM content. And if I select this hyperlink, it will take me to the service map for this front end service. And from here, I can view various APM metrics related to this particular service. Another thing that I'd like to point out that's different about the clusters in this organization is that I get a little bit more data for this infrastructure. And by that, I mean, if I scroll down to the metrics in the nodes navigator and select Kate's node logs, the logs are being pushed in this particular organization. And so you're able to see the system logs of these Kate's nodes, as well as some other log types. And in this organization, we have a much larger number of clusters, and within each cluster, a larger number of nodes that are running in the clusters. And when you have a much larger, more complex environment, this is where it's really crucial to be able to use filters to filter down to the components that you're looking for. Similar to the previous environment, if I take a look at the top right, you can see that there are active alerts that are being triggered, and a lot of these alerts are actually Autodetect detectors as well. Now, the Kubernetes navigators are a great way to dynamically see the state of your Kubernetes environment and troubleshoot issues, but you still might want to have a dashboard with custom charts that show metrics that are important to you. Splunk Observability Cloud has built-in Kubernetes dashboards that you can use to see additional metrics about your Kubernetes environment. And on top of that, you can copy those dashboards and create custom dashboards from the built-in ones. So let's take a look at those built-in dashboards real quickly for Kubernetes. If I navigate to the sidebar here, I'll expand it out and select dashboards. And from here, I can even search for the Kubernetes dashboards from this search bar. But if I were to just scroll down, I should be able to see Kubernetes built-in dashboards as well. And I can see right here, we have the Kubernetes built-in dashboards. If I expand that drop-down menu, I can then see all of the dashboards that we have available for Kubernetes by default. So you don't need to build these dashboards. I'm going to click into the K8s overview. And from these charts, you can view even more detailed metrics than some of the charts that you might find in the Kubernetes Navigator. And you can access all of the other Kubernetes dashboards from the screen as well. You wouldn't have to go back to the previous page. I can access all of the other built-in dashboards from this top navigation bar here. There's a dashboard for viewing all of the node metrics. If I want to see a single node, I can go to the K8s node dashboard and then specify a specific node. And then there are a number of other dashboards that I can select. I can look at all of the pod resources or a single pod as well. So before I close out this video, I just want to briefly recap the features that were covered in this video. The first is the K8s navigators that are located in the infrastructure page, specifically under the containers section, and then Kubernetes. Okay, and there are two types of navigators. There are the nodes navigator and the workloads navigator. From these navigators, you can view a lot of key metrics about your Kubernetes environment, but you also have this powerful tool called the K8s Analyzer, which will automatically identify issues in your environment, and it will try and group related Kubernetes components together by those problems. We also discussed the Autodetect detectors, which are built-in detectors that will alert you on some of the most common issues that you might find in a Kubernetes environment. You can find those alerts up here in the top right. Those detectors are also listed in the Detectors and SLOs section. And then finally, we took a look at the Kubernetes built-in dashboards that are available in Splunk Observability Cloud. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. Thanks for watching.